Okay, so picking up where we left off, we were about to choose an equation. So looking at our variables, we have t, a, vf, vi. No distance this time. So looking up at our equations, we have distance, distance. We don't want those two. Leaving us with vf equals vi plus at. That does work. So we'll copy this one down. And solving this guy out, we should be able to find how long it takes the car to stop. So plugging in, our VF is 0, our VI is 20, our A is -5, and our T is unknown. So unfortunately this time, we have a situation in which our variable that we're looking for is not being solved for. So we need to solve this equation for T. So the first thing we should do in this scenario is remove the addition first. So to do that, I'll do the opposite of both sides. So I'll subtract 20 from both sides. This will cancel, and I'm left with -20 equals -5t. To finish this out, I have multiplication here. To undo that multiplication, I should divide both sides by my coefficient, which would leave us, within this case, with t equals 4 seconds. So this car will take a total of 4 seconds to stop. But we still don't know if the kid's okay. We have to do one more thing yet, and that is figure out how far will the car go. What is the distance over this period of time when we're braking? And because we're talking about the same time, we actually get some nice things here. We actually know all the things we previously knew in the last scenario. We get all that stuff because we're talking about the same object over the same period of time. So in this scenario, when we look at what equation we want to use, if you notice here, this one works, so does this one. So we can actually choose whichever equation we want in this scenario. So I prefer to use this one. But I will tell you that either way we do this, we will get the same answer. So, you know what? I'm going to show both. All right, so if I plug into my first guy, I have d equals 1/2. Vi is 20. Vf is 0. T is 4. Over here we have d equals, and Vi is 20. T is 4 plus 1/2. A is -5 and T is 4, and that's squared. And both ways, if I enter the same exact thing in, because we are solved for D in both scenarios, we should get a correct answer. So here we go. Looking at the left hand side, we have 0.5 times 20 plus 0 times 4. Oops, I do not want a tangent. I want that. Okay, so if I look at the math here, I wind up getting 40 meters. And doing it the other way, we should get the same results. So here we have 20 times 4 plus 0.5 times -5 times 4 squared. And once again, we both get 40. So looking at our scenario here, the car will travel 40 meters. So the car will wind up being about 5 meters short of the kid. So in this case, kid is safe. That is good. All right. I'm probably going to show the last two. I'll do so a little quicker, just so you have two more examples of how to do these problems. So let's look at number 3. It asks us to find the acceleration. So I can already tell that in this case we're going to solve for A. That causes a car's velocity to change from 32 meters per second to 96 meters per second in an 8-second period. So they really have all these knowns front-loaded right in this area over here. So looking at our first number, 32 meters per second, we know that meters per second must be a velocity. And looking at this scenario, the context clues, it says from 32 to 96. So I'm pretty comfortable saying this would be the beginning speed, or the VI. On the other hand, our VF would be the other velocity of 96 meters per second. And finally, our T is going to be 8 seconds, because seconds can only be times. Looking at our variables and our equations, the equations we have access to, both of these have D's. We don't know anything about the distance, and we do not want the distance. So that kind of leaves us with the third one, which is nice because that one's not too crazy hard to use. So writing that one down, we have VF equals VI plus AT. And unfortunately for us, when we plug in, if you notice here, our equation is not solved out for A. So we will need to do a little bit of algebra here. So just like letter B, I'm going to undo this addition over here first. So I will subtract 32 from both sides. And that'll give me 64 equals 8A. I'll just rewrite that a little bit differently so it looks more familiar. And to undo this multiplication here, I'll divide both sides by 8, which gives me an answer of 8. So the acceleration here will be 8 meters per second squared. My final question, we have a cheetah who is chasing after a gazelle. The cheetah starts from rest, that's underlined, so that's bolded, so that's probably important, and quickly reaches a maximum speed of 22 meters per second. If it took the cheetah 6 seconds to reach its maximum speed, how much, there's a typo here, how much ground did the cheetah cover? How much ground is another way of asking how far did the cheetah run? So we are looking for distance once again. And pulling apart these other things, rest, that typically means that VI is 0, and it would make sense for the cheetah to start at 0 at the beginning of the chase. The maximum speed the cheetah reaches is right here, 27 meters per second. And then finally, the time is 6 seconds. So looking over our equations, we notice here we do not have an acceleration, and there is an acceleration, there is an acceleration. So that kind of leaves us with this guy up here. We want to choose this one at the very top. So D equals 1/2 VI plus VF times T. And hey, look, D's what we're looking for. D's already solved for us. This equation is going to be nice. We don't have to do any algebra. So plugging in, we have D equals 1/2 times 0 plus 27 times T, which would be 6. Okay, getting my calculator because I don't have to do any math besides just enter this in. I get 0.5 times 0 plus 27 times 6. So my answer in this case is D equals 81 meters. Okay, at this point, I would encourage you guys to begin working on the last questions of the homework assignment, the homework page. There are, I think, 11 questions in there. I'm not positive. But at this point, you should be able to complete the homework. Use the rest of the time today to complete that. If you get stuck, you can refer back to the videos at any time. Or you can even maybe ask somebody else who may get it for a little bit of advice. If you get horribly stuck, or if you get done, you may begin working on the balloon car lab, which is in slot 12 of the cardboard tower business. Tomorrow, next time when we see each other again, I will be available to help students out who may need a little extra work with this stuff. So, best of luck. Remember, follow the procedure, look at the knowns, take your time, and hopefully you find success with these problems. All right?